Okay, welcome back to the second part of this percentage change. Now I'm going to talk about decay factor. Before we talked about growth factor, but now I'm going to throw in decay factor. So when we're talking about decay factor, think about depreciation. In our previous lessons, we've talked about the A value would have to be between 0 and 1. Well, in this case, if you're looking at this decay factor, it is 0.4. So the easy way to do this is decay and growth are opposite of each other. So all I'm going to do is I'm going to take 1 is going to be, instead of adding, we're going to subtract 0.4. This gives us so all I'm going to do is subtract 0.4 from 1, and I get 0.60. That is what our growth factor is. However, we're looking for the percentage. So what we're going to have to do is we're going to have to, anytime you're looking for percentage, multiply this by 100. And that means that this is 60%. So 60% is really not a growth factor. It's actually this depreciation. But we're going to call 60, in this case, we're going to say the growth factor is 60%. Now, another one, same type. I give you a decay factor of 0.38, and I want to know what is the percentage of growth factor. So if you want to, you can pause this to work on it, and then come back and you can see if you've worked this correctly. So now what I want to do is I want to take, since it's a decay factor, you always subtract the decay factor from 1. So 1 subtract 0.38. So in this case, you get 0.62. Now, since this is actually a percentage, we need to multiply by 100%. In this case, we get 62%. So now what I want to do is I want to kind of apply to what we've seen so far, and I'm going to give you a growth rate, and I want you to find an equation. So if I give you this percentage growth rate at 4% and f of 0 equals 6. Now think about this for a second. We talked about anytime you've got 0 in parentheses, that's our x value. That's our initial value. So that means we start off with 6. I mean, whether it's $6, maybe it's 6 strains of bacteria, whatever the case is. So that's what we need to think about when we see this f of 0 equals 6. Now, what we need to do is we need to come up with an exponential equation. So, remember, going back to looking at our n of t equals our original initial value, 1 plus r to the t. So now we can start filling this in. Now, we know that the c value is 6. That's what we start off with. And it's going to be, we need to figure out what this is in parentheses. Well, look at our 4%. What I want to do is I want to take, since it's percentage, instead of multiplying by 100, I'm going to divide it. I get 0.04. I'm going to add it to 1. This gives us, goes in the parentheses, which in this case it's 1.04. So this gives us an exponential equation of 6 and then parentheses 1.4 raised to the t value. So that means, I can ask you, what happens in 3 years, 10 years, 20 years, and you should be able to use this equation to see what this initial value 6 turns into. Now, the last problem I'm going to demonstrate is this right here. Now, the problem says in the year 2000, the population of Frankfurt was 65,000, and it increases at 20%. So So I want you to find an equation in part A, and then in part B, it wants you to come up with an answer to what the population is in 2010. So let's think about, first of all, let's think about the equation. Now, so we'll just use this n of t equals, it starts off with 65,000. And it increases at 20%. So I want to take this 20, divide it by 100, and I get 0.2. I'm going to add it to 1. So I'm going to get 1.20. That's going to be what's in my parentheses. So this is the equation. It's n of t equals 65,000. Parentheses is 1.2 raised to the t power. Now, what happens in 2010 if it increases at this 20% rate? So now what I want to do is I want to come and think about, I'm going to still use that same equation, but what I want to do is I want to say n of 10, because that's our time, and then I'm going to say, okay, 65,000, parentheses 1.20, raised to now to the 10 power. Now, if we put this in our calculators, just like this, and we calculate, you should get 402,462. Now, all of this is going to pertain to homework number 11 on WebAssign. I hope this is helpful, and be looking out for some more lessons. Thank you very much.